Okay, morning everybody. This is Mr. Ndabezita once again, and we are still continuing with chemistry, and this time we will look at molarity and what really comes out of this. So I have prepared some few slides that might give us an idea as to what is happening here. So let's just get right into it. So molarity questions, we have the heading, and they say one of the most common units used to quantify the concentration of a solution is molarity. So this is a concentration of a solution that we are dealing with, which shows the number of moles of solute per liter of the solvent. Very important things that we need to note there. So we have a solute and a solvent, and this combination we call this a solution. So you will have the number of moles of the solute substance that is to dissolve inside of the liters of a solvent, and therefore forming what we call a solution, right? They say which shows the number of moles of solute per liter of the solvent. Okay, so the solvent has to be in liters and the solute has to be in moles. All right, so molarity is a term of measurement that can be used to determine the volume of a solvent. So we can determine the volume of a solvent, which is something of which a solute dissolves inside of, or the amount of a solute. So molarity, we can use molarity to determine the volume of the solute or the amount of the solvent. So we can find the volume of the solvent or the amount of the solute. And the formula C1V1 equals C2V2, which is the concentration, for example, of the solute, multiplied by the volume of the solute equals the concentration of the solvent multiplied by the volume of the solvent, where C is the concentration and V is the volume. Can be used to describe the relationship between two solutions containing the same amount of moles of the solute. So the solute has to have the same number of moles. Now remember, we said now the solute is this substance that we dissolve inside of a solvent. Very important. So it is used, the formula C1V1 equals C2V2 is used to describe this relationship between two solutions containing the same amount of moles of the solute. All right, definition. Molarity, also known as molar concentration, is defined as the number of solute present in a given number of liters of the solution, or moles per liter. So we have to find the solvent, the volume of the solvent in terms of liters, and we need to find the solute as the number of moles. Very important. So they say in the definition that molarity, also known as the molar concentration, is defined as the number of moles of the solute. So you calculate the number of moles of this solute substance present in a given number of liters of a solution. So the solution has to be in liters or moles per liter. So this definition of molarity is it has the SI unit of moles per liter, because remember we are saying C equals N over V, so it will have the SI unit of moles per liter. Okay, that is fine. Molarity chemistry questions with solution, differentiate between the solute and the solvent, and the answer, they say a solution is a component, a solute is a component that dissolves in a solvent to generate a solution. This is very true. That's exactly what we said. We said now you take in your solute and it is dissolved inside of a solvent, and what you have, that mixture of those two, is what we call a solution generate. So solutes can exist in three states. So this substance that dissolves inside of a solution, the solvent that dissolves inside of, the solute that dissolves inside of a solvent, we refer to that as a solution. And the very substance that we call the solute can exist in three states. You can have your solute as a liquid, a gas, or a solid. Solutes usually make up a smaller portion of a solution than solvents. Now let us make a practical example in this. When we go to the stores and we buy a concentrated juice, maybe you buy 500 for example, let's say you buy 1 liter of this concentrated juice, and it is written down that it is able to make maybe 5 liters when it is diluted. So you have this concentrated juice as your solute, something that will have to be dissolved inside of a solvent, which is water, and the two mixtures are called a solution. So normally, even in our practical everyday life, the amount of the solute is always smaller than the amount of the solvent, because it has to be dissolved inside there. So this is just what they are saying there. All right, so they can exist, the solute can exist in three states: liquid, gas, and a solid. So solutes usually make up a smaller portion of the solution than the solvent. We know this in practical. A solvent is a material that has the ability to dissolve other substances. For example, water has this capability. If you dissolve concentrated juice inside of water, so water has this ability to dissolve other substances. Solvents can exist in three states. So not only the solute can exist in three states, also solvents can exist in three states. So also as a liquid, a gas, and a solid. So the same for a solute, which can exist in three states. Also the solvent has three states in which it can be found. So they say that solvents are most typically employed as liquids. This is exactly the example that we provided. All right, be that as it may, let's continue in this. Right, mole fraction is defined as the number of moles of one component of a solution divided by the total number of moles of all the components in the solution. Now let us try to read that very slowly. Mole fraction is defined as the number of moles of one component of a solution divided by the total number of moles of all the components in the solution. All right, so we are so much interested on the fraction of the moles that are found inside of a solvent. So we are saying therefore a mole fraction is what now is the number of moles of one component of interest inside of a solution, and we divide that by the total number of moles of all the components in the solution. So for example, let's say maybe we have more than one substance which is a solute that we dissolve inside of a solvent. For example, let's take 3. Suppose we have 3 substances and they are all solutes and they have to be dissolved inside of a solvent in order to form this solution. So we are therefore saying the mole fraction, because we are having different substances as the solute that we are dissolving inside, we are interested as to find the mole fraction of each solute. Therefore, we are saying the mole fraction is defined as the number of moles of one component. So we have this one component that we are interested in order to find how many moles of it were dissolved inside of this solvent. So we are therefore saying mole fraction is defined as the number of moles of one component of a solution divided by the total number of moles of all the components in the solution. This is a pretty straightforward. So you will take the number of moles of one of interest and you divide by the total number of moles of every solute that was dissolved inside of that solvent. Alright, remember it's a fraction, and whenever you are adding all the fraction, they have to be equals to a whole number, which is 1. So we are saying the sum of all the mole fraction of a solution component is always 1. It's always equals to a whole number because they are fractions, they are divided, and when you add all the total, they have to equal 1, which is the entire thing. Right, okay, that's fine. And then in question 3, they say define mass percentage. The mass percentage of an element of a solution. So we want to find the percentage of this element, and it is defined as the mass of the solute in grams present in 100 gram of the solution. Very important, we are saying now the mass percentage. What percentage of mass was dissolved inside of a solution, or what percentage of the solute was dissolved inside of a solvent in order to form a solution. Therefore, the mass percentage of an element of a solution, remember a mixture of the solute and a solvent, is defined as the mass of the solute in grams present in 100 gram of a solution. So you can have the mass of a solute, you divide that by 100 gram, multiply by 100, and it will give you the mass percentage of the solute that was dissolved inside of a solvent that formed the solution. And it is written like this. So okay, that's fine. Question 4, 2 solutions of a substance non-electrolyte are mixed in the following manner. We have 480 milliliters of 1.5 molarity or concentration first solution. So this is the first solution. In the first solution, what do? We are mixing 450 milliliters of 1.5 concentration first solution. So let's make a practical example here. Let's say we have 480 milliliters of water and we have 1.5 molar concentration of juice, and we form this first solution because we have a solute and a solvent. Secondly, let's say we have 520 milliliters of water and we decrease the molarity or the concentration in the second one. What is the molarity of the final mixture? This is very, very important. And then we will have to answer that. So if they say what is the molarity of the final mixture, now we need to go back. We are saying mole fraction is defined as the number of moles of one component of a solution divided by the total number of moles of all the components in the solution. Now in this problem, we are given the concentrations here, not the number of moles as defined up there. So what is the molarity of the final mixture? What is the final concentration? Now let's read this again. two solutions of a substance, non-electrolyte, are mixed in the following manner. So we are mixing the two inside one beaker. So we have this as a separate and we have that as a separate, but we are mixing them together. But now what is happening, the first one has a 480 milliliter of this and we are mixing with 320 milliliters of that. What is the molar concentration? Now concentration equals number of moles divided by the volume. But now what is the molarity of the final mixture? We can just go on and add the two, because we can take this molarity here. We are interested in just the concentration, not the solvent. We are just concentrating on the concentration of this solution. So this is a solution, the first solution and the second one, and we are mixing the two together. What is the molarity of the final mixture? So they say this is a first solution and the second solution. So what is it that we do? We can just simply add these. We can add 480 milliliters with 520 milliliters. That will give us the total solvent that we have. It will be 1 liter, because this will give us 520 milliliter plus 480. That will give us approximately 1000 milliliters, and we can add the concentrations of 1.5 plus 1.2. that will give us 2.7. so this is exactly what we will have. But remember, this is just a concentration. Here we have the molarity. So molarity, remember, concentration, number of moles divided by volume. So we will have 2.7 per 1000 milliliters. That will be the molarity of the final mixture. In terms of adding the volume first, 480 and 520, and then adding 1.5 and 1.2, so we are having a molarity of 2.7 per 1000 milliliters. So that will be the molarity of the final mixture. We are just mixing the two, just as you would be asked a question when you are preparing juice. You have 480 milliliters of water with 1.5 concentration, and then you are having 520 with 1.2 concentration, and then we are saying what is the final molarity of this. You are adding these solvent by that, which is the 2 milliliters of water that you are provided. You just combine these two, and then you're also adding up these concentrations, and then what is your final molarity? That will give you 2.7 by 1000 milliliters. That will be the molar concentration of your solution. All right, that is fine. Concentration is a measurement of how much solute, which is the substance, is given the amount of the solvent, the liquid. Because this is exactly what we do when we create a concentration. We just don't do this randomly. That's why it's even written when you go inside of a store, they will be very specific as to say this concentration can only dissolve this much, or can be dissolved in this much amount of water, or whatever there is. So you need to follow the instructions that are provided. So when we have a concentration, when we have a solute, we have to give it a certain amount of a solvent. In this case, we will say a liquid. We have to know, if I have this amount of solute, how much can I dissolve completely inside of a solvent. So we don't just do things the way in which we want here. There's a certain amount of solvent and solute that needs to be mixed together in order to give out the flavor that you prefer. Should you exceed the limitations of this, then you know that things will not be favorable for you. So diluted solutions contain a relatively small amount of the solute. This is what we said. Concentrated solutions contains a relatively large amount of solute. Now let us look into this. They say diluted solutions contains a relatively small amount of solute, and concentrated solutions contains relatively a large amount of solute. And this is true. We know that in a concentrated juice you can have a large amount of solute, water, and in a diluted solutions you would relatively prefer to have a small amount of the solute. And this is very, very true, that in diluted solutions we normally have a small amount of solutes. So scientists measure concentration in molarity in this way, molarity, or that way. And molarity is the number of moles of the solute divided by the liters of the solvent. So it has to be in liters. Or molarity, M, or micro symbol, equals the moles of the solute divided by the kilograms of the solvent. Very, very important that we note this. You can measure molarity as moles per kilogram or as moles per liter. So when you are given kilograms, work with kilograms, but you will have moles per kilogram. When you are given liters, work with liters, you will have moles per liter. All right. Molarity problems worksheet. Molarity is equals to the number of moles of the solute divided by the liters or the kilograms of the solvent. Very important, where N is the number of moles and V is the volume in liters or in kilograms. We saw that. Use M or mole per liter as the unit of molarity, or we can use mole per kilogram. Do not forget. Remember that 1 liter equals 1000 milliliters. Do not confuse ml and ml. Some problem ask for volume by algebra. Volume equals N divided by M. We can see that here. Volume is equals to N divided by M. Some problem ask for number of moles, and number of moles is the product of volume and molar concentration of a solution. And then we have these things here. Okay, that is fine. We have dealt with many of these. And then the volume of a solution is affected by the temperature. So they say the volume of a solution is affected by the temperature. Thus, the formula for concentration that includes volume will change as temperature changes. So temperature has a major impact on the volume, the volume of the substance. So this is very true. We know that an increase in temperature will affect the volume and so on. All right, now let us try to find some of the problems that we can practice with in order to find out exactly how things should transpire. So let me just do this. I will just come back after a few minutes. Okay, now let's continue in this and check. So we have what is the molarity of a solution that has 5 moles of solute and 2.05 liters of the solvent? So we can just go to the calculator here just to find out what is happening. So we know that the molar concentration of a solution is equals to the number of moles that are provided to us, which is 5, and we divide that by the liters of the solvent, which is 2.05, and when we press on the answer, we get that 2.44 there. So this concentration is measured in moles per liter, or you can just say molarity there with a capital M. So that was just a direct thing. So we are therefore saying if you have 5 moles coming from the number of moles of a substance that we dissolve, suppose this can be anything, maybe sodium chloride or just anything, you calculate the number of moles by saying number of moles equals mass divided by the molarity, molar mass, the weight of the substance, and then you get the number of moles, and then you just dissolving those moles inside of the liters of the solute of the solvent. So you will get that answer of 2.44. So when we divide the number of moles divided by the solvent, which we can say this is the solute, so you have 5 moles of the solute and 2.05 liters of the solvent, and this gives you a concentration. All right, that is fine. Let's go and look at the second one. I think we're going to do the very same thing. Calculate the volume of 1.5 molarity solution that contains 4.2 moles of the solute. Now we are looking for the volume, and let me just take you back. And if I take you back, I think it was on this slide, we said now volume equals number of moles divided by molarity. So you take the number of moles and you divide by molarity. So we are here. So we are going to take the number of moles. Okay, they are looking for, okay, sorry, we are in this one. Calculate the volume. So we take the number of moles, which is 4.2, and we divide that by molarity, and the molarity it's 1.5, and we find the volume as 2.8 liters. This is very, very important here. Calculate the volume of 1.5 concentration solution that contains 4.2 moles of the solute. So somebody might say liters here, or somebody might say 2.8 kilograms, because we saw that the concentration can be given as moles per liter or moles per kilogram, but here we just decided to use the liters here. But somebody can say 2.8 kilograms, because we use kilograms and liters interchangeably. So when you are given the concentration and you are given the number of moles and you were to find the volume, just use liters, just as in this problem. How many moles of a solute are in 8.5 liters of 0.55 molarity solution? And we saw that the number of moles, where was that? Let me just take you through that. We saw, where was it? Number of moles equals volume multiplied by molarity. So in order to find the number of moles, how many moles of the solute, so in order to find the number of moles, we just multiply the two. So we will just say 8.5, we just multiply that by 0.55, and we just find that as 4.675, which is 4.68 if we are to round off to 2 decimal places. So these are the number of moles. So we are therefore saying we require 4.68 moles in inside of 8.5 liters in order to have a concentration of 0.55 molarity. Very, very important. So these number of moles are required inside of 8.5 liters to produce that molar concentration of a solution. All right. How many liters of 12.0 molarity HCl would you need to make 1.2 liters of 3.5 HCl? How many liters? So we are looking for volume, and we know that volume is the number of moles divided by molarity. Let me just do this very quickly. Okay, we can just continue in this. We are looking for volume, so we are just taking the number of moles and we are dividing that by molarity. So this is something very simple to be done. You are just let me just do this. We are just taking the number of moles. How many liters of 12 molarity HCl would you need to make 1.2 liter of 3.5 molarity? Now there are two different things that are provided here. We are provided with a two molar concentration of two different things, so we need to go for a formula. M1V1 equals C1V1 equals C2V2. Very, very important that we use that formula. So what I'm going to do now, how many liters of this one would you need to make 1.2 liters of that one? So okay, that is fine. I'm going to do this. I'm going to say 1.2 and I'm going to multiply that by 3.5, and I will therefore divide that by 12.0, and that should be enough to provide me with the volume that I need. So please be very careful here. You are given two concentrations. You have the first one, but you don't have how many liters. You have the first one, the second one with its own liters, 3.5 and 1.2. So you have 12.0, but you don't know the volume of the first one. So you use C1V1 equals C2V2, and it will provide you with that answer. Okay, what would the molarity of a solution be if you took 2.5 liters of 1.5 sodium hydroxide and added enough water to make the total volume of 8.2? Now here you also need to look at the data that you have. You have what would the molarity of a solution be if you took 2.5 liters of 1.5 sodium hydroxide and added to water to make that? So we are pretty much going to do the very same thing as we did previously. So you have 2.5 liters of 1.5, so you would just say 2.5 by 1.5 added to water to make that. So we are going to divide by 8.2. And one most important thing to look at here, we have this in liters, we also have that in liters, so there's no need for us to convert in here, and then we can just find the answer as 0.457 as the molarity there. So these are just straightforward questions. No need to stumble upon this. Okay, now let us continue. Molarity example: if you add 0.5 moles of sugar to 2.0 kilograms of water, what is the molarity? We know that it can be calculated in liters or in kilograms, so there's nothing new in here. So what we are going to do, because they say what is the molarity, we know molarity equals the number of moles divided by the kilogram that are provided, which is 2.0, and you get 0.25 watt. 2.5 molarity, or 2.5 moles per kilogram. Very, very important that we understand that. Okay, that's fine. Determine the molarity of a solution of 5 moles of sodium chloride in 620 kilograms of water. And you are given a hint there, 1 kilogram equals 1000 grams. So we are just going to divide this by 1000. So what I'm going to do, I'm just going to say I'm converting this to kilograms. So I'm just going to say 620 divided by 1000, and I get 0.62. So what I can do now is to take, because they say what is the molarity, I'm taking 5 moles divided by 0.62, and that should be enough to provide me with an answer of, this is, okay, I'm sorry guys, I was just disturbed. I remember very well that we were in here. So let me just repeat this very quickly. I'm going to leave Camtasia right in here. It has a tendency of not recording. Okay, let me just wait. All right, let me just put it somewhere around there. Very good. So what we are going to do, just to look into this, so we know they say determine the molarity of a solution of 5 moles. So the number of moles are provided, 5 moles of this. So what I'm going to do, first of all, I'm going to convert this into kilograms. So I'm going to say 620 divided by 8000. Right, okay, that is fine. I know this will give me the volume in kilograms. Okay, that is fine. And then from there, I now want to calculate the molarity. I know it's the number of moles which I have here divided. So I'm going to say 1 over divided by okay, let me do this. Here I was just converting the mass, but I know concentration is the number of moles, which is 5, divided by what? Divided by the volume. Very, very important. So what I can do from here, let me not do it in this way. Let me just say 5, which is number of moles, divided by, and I can now say 620 divided by 1000. Sorry, let me just do this. Right. So this is the same as just saying the number of moles divided by the volume. So this is pretty much the same thing. I am just converting the volume here from grams to liters. And then from there we can just try and find out what the value should be. And this is the value that we get. So this is the value that we get. So it's 8.0645. Somebody might do it in this way, or you might first want to say 620 divided by 8000, and it would give you 0.62. So you can just say number of moles, which is 5. You can just say 5 divided by 0.62, and it would provide you with exactly the same answer. So this is just basically how we calculate that. All right, and then from there we can continue with this one. How many moles of 2-butanol must be dissolved in 0.125 kilograms of ethanol in order to produce 12.0 mole or molar concentration? Right now, so how do we do that? So first of all, we understand what the formula is about. So they are looking for how many moles. Now I know that number of moles, concentration equals number of moles divided by volume. Therefore the number of moles equals volume multiplied by the concentration. Okay, that is fine. So I can take 0.125, which is the liters, and I can multiply this by the concentration of 12.0, and you would get an answer of 1.5. So 1.5 is the number of moles. So we need 1.5 moles inside of this 0.125 kilograms in order to produce a molar concentration of that solution of 12. So these questions are not that difficult for one to solve. Okay, let's just go to the last one because we have completed this one. So when we are here, I'm going to try and integrate many things in this calculator. So they say how many moles of a solute are in 125 milliliter of 2.0 molar concentration hydrochloric acid. So how many moles? I know that I have to take the volume and multiply by the concentration. Now remember, the volume must be either in liters or in kilograms. So I have to convert this to liters. So how do I do that? I'm just saying 125 milli means times 10 exponent of -3, which is the same as dividing by 1,000. All right, and then from there I have just converted this to liters. So I must take these liters and just multiply that by the concentration of 2.0, and I would find an answer of 0.25 moles of hydrochloric acid. So we need 0.25 moles of HCl inside a solvent of 125 milliliter in order to produce a concentration of 2.0 concentration. Okay, that is fine. Let's go to number 8. How many grams of magnesium chloride are contained in 0.50 liters of this? So they are looking for mass, but we can find the number of moles first because we have the liters and we have the molar concentration. So let's find the number of moles by finding the product of the two. So we are given this in terms of liters. So I'm going to say 0.50, and I'm just going to multiply that by 1.5. And that is going to give me 3 1/4, which is 0.75. So I'm going to insert this answer inside of the brackets. Sorry, this is the answer that we have. And now what I'm going to do, right, now that I have the number of moles of magnesium chloride, what I'm going to do is to find now the mass, because I have the number of moles which are inside here. So I know mass is equals to the number of moles multiplied by the molarity. So number of moles, here they are, and I know I have to take number of moles and multiply the number of moles by the molar mass, the weight of magnesium chloride. So what I'm going to do, I'm just going to go to my calculator. I know that chlorine, it's a 35.45, sorry, 4521. But how many chlorines do I have? 2 chlorines. So I'm going to multiply this by 2. Very important. Plus, remember you are calculating the molar mass here. And now we go to magnesium. So I know that magnesium has a molar mass of 24.3051. Right, and this should give me exactly the answer that is required. So the answer is 71.41 grams of magnesium chloride. So the individual here just decided to get rid of the significant figures. These values are so important in chemistry. So this is the answer that I have. So the first thing that I did here, because they are asking for the mass of magnesium chloride and they have given me the liters and the concentration, I'm going to use the formula number of moles equals the volume multiplied by molar concentration. That will give me the number of moles. And then after that, I know that the number of moles equals mass divided by molar mass, and mass equals number of moles multiplied by molar mass. And this is exactly what I have done. So we just find those answers. Now let's check this one. What volume of 0.1 concentration of sodium hydroxide could be made with 20 grams of the solute? So we need to convert this into the kilograms. Very much important. So I know I will just divide this. So what I'm going to do, first of all, they say what volume of this could be made from that. What volume? I know concentration is equals to number of moles divided by the volume. So if concentration is equals to number of moles divided by the volume, that is to simply say I can just find the number of moles. So how do I find the number of moles? I just take the concentration and multiply that by the volume. So I'm going to do this. I'm going to say, okay, I have 0.1 and I am going to multiply that by the liters, but this is in grams. I need to convert this to kilograms. So I'm just going to take this 20.0 and divide, because I'm moving from a smaller number to a bigger number. You divide by 1,000. The conversion factor between grams and kilograms is 1,000. And we saw that. Let me just take you back where this was made very plain. Where was it provided as a hint? I think there was somewhere where a hint was provided. Here, 1 kilogram equals 1,000 grams. So when I'm here, let me just do this. There it is. So what will this provide to me? This will give me the number of moles. Right, I'm going to do this. Okay, let me not do that first. Let me say equals, and then let me do this. So we have the number of moles for this one. Sorry, are we on that one? Sorry, we are here. So we are having here the number of moles. Now we are looking for volume. Very important here. So we have the number of moles, what volume of 0.1. This could be made from 20 grams of the solute. Okay, let's wait a little bit here. This 20 grams of the solute is the what volume of this sodium hydroxide could be made. So we have 20 grams, which is the mass of sodium hydroxide. Please, let's be very careful with that. Let me do this. We have the mass of sodium hydroxide, and we can calculate the number of moles here. Please be very careful. We can find the number of moles, and I know that number of moles equals mass, which is 20.0, and I divide this by the molar mass of sodium hydroxide, and I know that sodium has 22.98 grams per mole. That is sodium. The molar mass, I go to oxygen, and I know that oxygen has a molar mass of 15 point, so this is 15.9994 plus the molar mass of hydrogen, and that of hydrogen, it's 1.008. And when I punch this on the calculator, what is this now? This is the number of moles. So I have the number of moles now. And what is it that they are looking for? They are saying what volume of this. So they are looking for volume. So concentration equals number of moles divided by volume. Therefore, volume equals number of moles divided by the molar concentration of a solution, which is 0.1. And this should give me the amount of liters that are required. Okay, let me just, I'm trying to bring this. Guys, the computer is very slow. I don't know why. Can I just take this there? Okay, there it is. So here we are, and we have 5 liters of sodium hydroxide. So this was just a pretty simple problem to deal with. So I think you will deal with this one, and that one. But okay, for interest sake, let me just do this one. How much water, which is the solvent, should be added to 5 grams of potassium chloride to prepare 0.5 molar concentration? So how much of water? So this is requiring the volume. Okay, that is fine. We have the mass. We can find the number of moles because it is the mass. Divided by the molar mass of sodium, of potassium chloride. So I can go to potassium, and I know that potassium has a molar mass of 39.0983 plus, it's not only potassium but also chlorine. So I know that chlorine has a molar mass of 35.4521 grams per mole, and I get this answer. What is this? These are the number of moles. So once I have the number of moles, remember they say how much of water, which is the volume, and concentration is equals to number of moles divided by volume. Therefore volume equals number of moles divided by the molar concentration of a solution, which is 0.500, and that should give us an answer of 0.134 kilograms. Why? Because remember, we are given how much of this should be added to that molar concentration. So your answer, it's going to be in kilograms, because we are having our mass here. So the volume will be in kilograms, and then if we had liters, it would have been in liters. But we can convert that to liters. It doesn't make any difference. So this is the answer that we have. So this is something very important that I thought we should share: the molar concentration of a solution. These are just the standard problems that you should know. Just giving you the basics there is. In the second tutorial, we are going to deal with more hot stuff.